wanted to cut 3 but okay.
Since a period is pi over 2, to make this work nicely, I'm going to make my 4th tick mark pi over 2 because I know the 4 points I have memorized on sine, I can work with those nicely if I make the period a full 4 tick marks. Sine normally starts at 0. This one is no different. It normally goes up to 1. This one, instead of going up to 1, goes up to 3. Oh.
So sorry.
I was just testing. Okay, so it's cosine, that's like, so cosine starts at 3 and 0, then, oh, that's too much in there. Negative 3, and then 0 and 3. That is 1 period. Now pay attention to directions. There were a couple on your homework last night that asked you to graph from negative pi to pi. If I needed to graph this from negative pi to pi, what would I need to do? Go on the other side. Would that be enough?
We need to do it twice.
I'd have to do it twice on each side because this one goes to pi over 2. So if I wanted to go from negative pi to pi, I'd have to actually do 4 periods in there. Does that make sense?
That's 1 period.
This is 1 full period. Now some of them will ask you to graph 1 period. That's 1 period. If it asks you to graph 2 periods, you could go either backwards and do another one or forwards and do another one either way. But if it said to graph from negative pi to pi, I would need to make sure to go all the way out to pi and all the way back to negative pi. Does that make sense? So we said this yesterday, but didn't actually do it. And this is a little differently than I do it. I'll show you where this is out of your textbook, I think. I'll show you where my differences are a little. But steps to graphing sine and cosine. Step 1, find a period. And I would even add to that, go ahead and find an amplitude. Find a period and amplitude. Start with 0 on the x-axis and lay off the distance to the period, and I would lay that off with 4 tick marks. Right? If you're working with a pre-existing graph, I would make 4 tick marks out to the period. Find where the period was, and then I'd go back and make 4 tick marks backwards and find those fourths, because I need those for my points on sine or cosine. You are always working with graphs that you get to label the axes, but if for some reason you had to do one that had a pre-existing axis, you would go back and make your own marks and make 4 tick marks. Step 2, divide the interval into 4 equal parts. Step 3, I do completely different. They say evaluate the function for each of the 5 x values resulting from step 2. Memorize them. Don't evaluate them. That's a waste of time. Memorize them. You know what I mean by that? What they're wanting you to do is after you found those 4 tick marks, they're wanting you to go, if we were on this one back here, they're saying, okay, if that's pi over 2, then this is pi over 4, and this is pi over 8. And they want you to go plug in pi over 8 into cosine. And then 4 times pi over 8 would give you pi over 2, and cosine of pi over 2 is 0, or 1, right? 0. So cosine of pi over 2 is 0, and so you would plot. Do you see what I mean? That's what they want you to do. They want you to literally plug points in and find values. To me, that takes way too long, because there's only 5 points. If y'all are smart, then you can memorize 5 points, and then you just put them down where they go. But if you ever forgot one, that's an option. You could go plug it in. But to me, that's a little longer than. So on my step 3, I would put memorize the 5 points. Sine has 5 points, cosine has 5 points. Just memorize where they go.
Oh, okay, yeah.
That one, this is the cosine set. Let me do that in red so anyone at home can see your answer. Those are the 5 points on cosine. On sine, they're the same except 0, 1, 0, negative 1, 0. So if you just memorize that general shape, just like you did in Algebra 2 with a quadratic and an absolute value, it'll save you a lot of time rather than having to plug in and find those values. To me, that takes time. But it's not. You're welcome to take double the time on your homework if you wish that. Okay, step 4, plot the points. Join them with a curve with amplitude. So here's where they take into account the amplitude. Something they didn't mention was reflecting. If there is a reflection, do that as well. And then draw the graph over additional periods as needed. That means go look at the directions and see how much of it they told you to graph and answer the question accordingly. They say to graph 2 periods, graph 2 periods. They say to graph from negative pi to pi. Do it. Do whatever the question says. When A is negative, so this is where they take into account the negative. Then you have a reflection across the x-axis. You probably knew that. But negative amplitude, there's never a negative amplitude. The amplitude is a positive number. The negative number reflects the function of the y-axis, the x-axis. So, today we're not learning anything new compared to yesterday. We're just going to focus on it. I'm going to do a couple with some strange periods. Graph sine of 1/3 x over 2 periods. Miss Lowe taught this so well in Algebra 2. I imagine this almost feels a little bit boring, right? What do I mean she taught well? Because she didn't teach trig functions.
Like the
reflections and all of those things you've done before, stretches and shrinks. The new thing is that we have sine, cosine, and then the period is a little bit new because you only had to shrink 2 points or stretch 2 points instead of 5. For the most part, this should feel pretty familiar. What's the first thing that I'm going to find to graph sine?
the amplitude.
The amplitude and the period. Amplitude is 1 because there's no number in front. And the period is 2 pi divided by 1/3, and to divide fractions, you flip the second fraction and multiply. So you get 6. Okay. Sine starts going too fast. Okay. Sine starts at 0, 0. Goes up to 1 because the amplitude is 1. And that is 1 period of sine. Covers 1 full sine. What did it ask me to graph? 2 periods. So I can either go 4 more tick marks to the right or 4 tick marks back to the left. And I'm going to follow that same pattern. Yours will look a lot better on your grid paper. It's not the same width all the way across. Your grid paper will look a lot better. Any questions about that one? Okay, now you for the cosine of 2x. First thing I'm going to find is the amplitude and period. What is the amplitude? Positive 1. Remember, amplitude is always a positive number. So when I ask for amplitude, make it positive. Period is 2 pi over 2, which is pi. And I am going to make that mental note, though, that I almost wanted to make amplitude negative, which means what? Good, there is a reflection over the x-axis. definition of amplitude? It says it's positive force. It's actually negative. It's always the opposite. So the amplitude is the height of the wave. And it doesn't change the height of the wave, whether it's positive or negative. Okay. Pi is my fourth tick mark. The amplitude is 1. Cosine normally starts at 1. I'm going to go ahead and draw the original before I reflect it. But I am okay if you can reflect this all at once. You don't have to show both. If on your homework you do show 2 graphs, somehow let me know which one's the right answer. Either highlight it or put a line with an arrow to it that's its final answer or something so that I know which one for me to give me the answer. I am fine with you doing one. So this is a normal cosine graph of the period of pi. So we are going to reflect that over the x-axis. Any questions about that? Good. So the blue one, we're doing homework. Let me know that that's your answer. Let's skip the -3 sine of 2x. I feel okay with skipping that. I do want to do one with a strange period. So I want to do the 2 cosine of pi over 2 times x. What is the amplitude? And what is the period? What do you think?
4.
I agree. It's 4. How'd you get 4? Flipped the pi over 2, so you get 2 over pi. And so 2 pi times 2 over pi. The pi's will cancel and you get 4. Do I need to write that down? So we get 4 as our period. Remember, pi is a number. A lot of times y'all start to think that it just goes there or it's a unit. Remember that's a number. So if the period's pi, if you were to graph it on your calculator, it would repeat after about 3.14 units. This particular graph repeats after 4 units, not 4 pi. So if I were really graphing this on my calculator, this would be 1, 2, 3, and 4. Those would be the numbers on that axis, not pi's, because they just aren't in this. And so the amplitude is 2, it's a cosine graph, it's not reflected. It says only 1 period, so that covers it. So 2 periods, I would go some more. If it said to graph from -pi to pi, I'd have to cut my graph off about right here. Because that's about 3.14. So if for some reason this one said to graph from -pi to pi, it would be cut off in a weird place. Okay, now we're going to go backwards. Each function graphed is in the form y equals a sine of dx or y equals a cosine of dx. Determine the equation of each function. Technically, you could make any of them sine and you could make any of them cosine. But we're going to go for the easiest graph possible. So, glancing at this, what type of function do you think you would want to make it? Cosine. Why? It starts out at 1, or 2, so it would be easier if we use cosine. So I'm going to pick this one. What are some things that are pretty easy to pick out?
The amplitude.
And what is the amplitude?
2.
Okay, so I know it's y equals 2 cosine of something. Is the period 2 pi? No, if it were 2 pi, then it'd just be cosine of x. But since the period is pi, I need to do a little work. Some of you can do this in your head, especially on this one. But just so you'll know for later, if it got complicated, how to do it. I know that 2 pi over b is the period. So 2 pi over b equals pi. And then I would solve that equation for b. Again, this one you can do in your head, but if you couldn't, you would cross multiply and solve for that b. So what do we get for b?
2.
Really quick, I went over that too fast. How did we know? How did we know that pi was the period? Okay, cosine starts up here. How long does it take for me to get back where I started, right? And so make sure that that's what you're thinking when you're thinking period is how long does it take for it to complete a full wave? Questions about that one? Which one would be easier, sine or cosine?
Cosine.
I agree, cosine. Why would you pick that? It starts down at -3, so cosine is if it starts at the top or at the bottom. Sine is when it starts at 0. Now we know that we could shift it left or right, but we haven't done that yet, right? Tomorrow we'll talk about left and right and up and down shifting, but today we haven't done that yet, so we're going to have to pick cosine on this. And I do think it's a negative cosine. Why negative? Starts down. So I know it looks something like that. Now let's talk about the period. What is the period?
4 pi.
How do you know it's 4 pi? It hasn't completed a full wave yet, has it? It's completed half of one, not 2 pi. So I can envision that to complete a full one, I'd have to go all the way to 4 pi. So the period is 4 pi. And I know that period is 2 pi over b. I need to know what b is. Yes, cross multiply and divide. You will, if you do this enough times, you'll notice that you end up dividing the 2 pi by the period to get to b. 1/2. Over this is 1. Any questions about that? Yes. Okay. You have 2 worksheets. One was due today. The next due today. We'll get that at the end of the month. And then the other one is due on tomorrow. Only the first 6 problems. I do not recommend trying the other 9 problems yet. We'll do that tomorrow. I'll teach you how to do those. They'll take into account